Hello everyone. Welcome to utilizing aPriori for a should cost of complex geometries. My name is Emily Wright, and I'm an expert services consultant at aPriori. I'm joined by Tristan Evans, a lead should cost engineer at Carrier. So yeah, now I'll hand it over to Tristan so we can begin.
Thanks, Emily. And I just want to say hello to everyone. And today we're going to be talking about utilizing aPriori for should cost of complex geometries. I just want to run through a quick agenda. I want to begin by introducing both myself and Carrier as a whole. And then I want to introduce you to the group that I help lead here at Carrier that directly affects just about all business units that we have. Then I want to talk about the benefits of should costs and how it's been helping us grow our company over the past year. Then we'll talk about the actual rotor geometry itself with additional what potential savings we might get, and then how that relates to future goals and the benefits of aPriori. Lastly, I want to finish up by showing you the broader potentials of should costs and what we have planned for it over the next year. Quick intro of myself. I graduated in 2019 with a bachelor's in mechanical engineering. And then shortly after that, I started here at Carrier in May of 2019. I quickly, through my career here at Carrier, was tapped to be the should cost lead engineer of our group in October of 2019. And then since, I've been helping to drive the setup of our aPriori deployment and also helping to lead the should cost team across all Carrier product lines. For a quick rundown of Carrier, we have three traditional business units that we're split in. Traditionally, we've been known as the HVAC company, but we actually have a much broader revenue stream. Currently, we are about 19 billion in 2019 sales, and we split it up three ways. About 50% of our business is HVAC, both commercial and residential. Then we have our refrigeration business. This is transport and commercial. Traditionally, we think of this as the truck and trailer business. That's about 20%, and then the rest of it is in fire and security. This is a relatively newer addition to our business, especially since as a person that just graduated college, I was not even aware that Carrier did this. This involves anything from smoke alarms and fire extinguishers all the way to home security. We employ about 50,000 people worldwide with 80 plus brands. And we're about 50% in the Americas, about 30% in Europe, Africa, and Middle East, and then about 20% in Asia. These are the current global trends that are driving our business and what propelled us into creating a should cost group to begin with. Traditionally, we've always looked at efficiency, which involves the climate regulation. As we all know, global warming is becoming even more prevalent in all businesses, and ours is no different. We're looking at everything from the compressor all the way down to the PCBAs and making our products more efficient and better energy. Also, we're looking at urbanization. As you know, a lot of the population is currently moving to cities, especially countries such as the US. Because of that, we're getting even more energy density in these populations. And because of that, we're trying to help make better products according to this trend. Also, we have a growing middle class that's becoming bigger every day that is helping to propel our products into more households. Then lastly, as a legacy company, we have traditionally not been big into digitization, but we're quickly coming up on an era where everything is on digital. And so accordingly, we're trying to comprehend how to get our products more digitized. Now into more of my area. For should cost, there's two main drivers of this, helping with negotiations and also design for value. Two traditional groups that we're looking at. We're looking at supply chain, and then we're looking at the actual design engineers themselves. We always start out with a starting point, specifically a question. What are we looking at? Are we looking at a new product? Are we looking at an old product? And what is driving this request? Traditionally, if it's supply chain, as I said, that's driving towards negotiations. For a design engineer, it could be that they're trying to just pull costs out, and that's why they're contacting us. We traditionally do a bottoms-up estimation. We actually have a lab right here at our Syracuse facility where we actually do tear downs of all products. And when they arrive, we start right out of the box and we tear them down to the final components. It's a comprehensive model. It built upon a cross-functional team. We have team members that specialize specifically in all areas, such as PCBA, stock machining, and also casting. And then we try to highlight the process optimization, whether it be for negotiations or design for value. We try to tell you what you're looking at by looking at the cost drivers and also just trying to optimize the manufacturing process itself. But it's important to note what it isn't, and it's not a magic number. It's not creating a vacuum. Right now, what we can do is we traditionally work with whoever is requesting this, and we try to help them figure out what information they have so then we can better judge on how to get this request done. If we get more information from them at any time, we always go back and incorporate it to make a better, more accurate should cost. A priori at Carrier specifically. Really, we are wide ranging in the requests that we get. So accordingly, so is our a priori deployment is quite wide ranging itself. We use just about every process setup from sheet metal all the way down to PCBAs and wire harnesses, and also some newer technologies such as additive manufacturing. A priori itself, we've been using about every VPE under the sun, all 80, if I remember correctly. And then we also have several that we have personally created here in-house. And going forward, we plan on creating even more VPEs. It's important to note, though, that as I said, we have a cross-functional team. We traditionally have a subject matter expert that is on every single one of these process groups. So that way we can more accurately give a should cost, and that way there's no doubt that we have the knowledge. I kind of want to walk you through now our should cost workflow. We start out with initial requests, as I said, but what spurs this request can be a couple of things. As I said, traditionally about 90% of the requests we're getting in right now are from supply chain, but we are working hard at trying to get design engineers to come to us sooner so that way we can better assess the costs and maybe tackle some of the costs earlier, which as products go through the lifetime, as you know, it just becomes a lot harder to get costs out. Once the request is formally made, then we talk to the requester themselves. We try to compile as much of the basic information as we can. Sometimes it's relatively hard because a lot of our products are very old, and sometimes it's hard to estimate some of the volumes even. Once we have all that though, then we can actually start creating the model. Now, as I said, we're a legacy company. We've been around for a very long time, and because of that, some of our products don't even actually have 3D models. Because of that, what we have to do is use our 3D scanning ability, and then people on staff can actually recreate the 3D models. Sometimes our team is even requested to help out on just creating models themselves without even going into cost because of that ability. But either way, once we have this model, then we can go into aPriori and create our costing. By doing this, what we can do is walk through every step of the way and show these people what we have accomplished throughout the process of the cost model. And we can actually show them granular data that maybe they didn't think they could get. But once we have all that information, and then we get it verified by our subject matter experts here on staff, and also verify it with a requester to make sure that that's exactly what they need. Our customers are people in Carrier. That is the unique part of our group. Now getting into more specifics on the screw rotors themselves. Traditionally, Carrier has three types of compressors: reciprocating compressors, screw rotors, and also centrifugal. Each of them have varying use cases. Traditionally, screw compressors have had two designs, dual and tri-rotor. Specifically today, we're going to be looking only at dual rotor though. And the problem with these screw rotors is that traditionally, they are extremely hard to manufacture. And because of this, it's been hard in the past for us to get a should cost model out of it, and thus we can't see any potential savings. We spend about 13 million in 2019 alone on just the rotors, and we produce about 12,000 screw compressors a year. It's also important to note then the screw rotors themselves, a very small change can lead to big efficiency impacts. The helix angle alone can account for a lot of the efficiency that you can see out of these rotors. But they're very efficient, and we expect that going forward, a lot more of our business is going to be tied up in screw compressors themselves. The difficulties in the model itself, looking at the model, I think a lot of people would say right off the bat, it's difficult to see it. I mean, you have not only the gear hobby, you also have the grinding, and also out of that, just plain stock machine for your tail shafts as well. Out of all this, you have the male rotor that is sand casted. So now you're adding another process that would be traditionally very hard to achieve in just your traditional Excel sheets or your traditional should costing softwares. You also have, as I said, difficult geometry. You have the helix angle and other things that create a lot of difficulty in using traditional Excel sheets and other should costing softwares. You have a high finishing tolerance. Because of how the rotors mesh, we have to be very precise in making sure the rotor match each set so that they mesh correctly. Otherwise, you could lead to them binding together, and then the compressor ultimately will fail in the end. You also have very high surface finishing tolerances, and not only on the surfaces of the rotors themselves, but also on the tail shafts for the bearings. And then finally, you have a high inspection requirements due to the fact that these are going to be not only have to last a long time, but also because of the amount of work that has gone into it. Lastly, you have to look at the fact that this is our first should cost model that we've ever had on these rotors. So we don't really have a lot of backup data to go back to and incorporate into this model. Because of that, there's really no way for us to do a cost estimation on these without a 3D model. So well, that is what brought us to aPriori. Going through our savings potential. It took, and it's important to note, when we first started the aPriori deployment over the past year, at first we were not able to do these rotors. But I think over the past year, we've worked quite a bit with aPriori. And because of that, we've been able to achieve a really good cost model out of this. We're looking at a potential annual savings about $200,000 per year on just one set of rotors. And because of this, when you look at all sets of rotors, you're looking at potential savings in the millions. Realistically, of course, we're not going to be seen as high as that, but these are the potential savings that our negotiation teams can go out and try to get. Also, it should be noted here that what we're really looking at is about a couple hundred bucks in savings on each rotor itself in the set. So because of that, we're looking at a lot of good savings that we otherwise would never have had we not used aPriori. And I kind of want to go through the benefits now of this for us. First off, aPriori, it's an incredibly useful tool in the fact that we can create different changeable digital factories. Because of that, we've been able to go in and precisely create digital factories based on the suppliers of these rotors. And not only that, but also other should costing requests that we've had over the past year. We can change our manufacturing times accordingly, especially on these rotors. It was incredibly difficult to make sure to get an accurate time. As I said, there's a lot of grinding, surface and cylindrical grinding that goes into this. And because of that, there's a lot of added time, and those are really your big cost drivers in creating these rotors. As I also said before, the 3D model basis in aPriori is incredibly important. Without it, we would not have been able to do this cost model. And then the connecting of the casting and also machining. As I said, these rotors are now sand casted, and because of that, that adds another level of complexity to your rotors that you otherwise would not have had, and it becomes more difficult to use any other software. And then lastly, we can easily include our tolerances right down to every little nook and cranny. And because of that, we can also do our balancing and also rotor matching in aPriori. I want to talk now about what we have on the horizon. As I said, our should cost group itself, it's a fairly small team, but we do a lot of work for our size. Starting with, I went to the aPriori conference last year, and because of that, I saw the Alstrom presentation that they gave, and also I saw, as I hope most of you did, yesterday they gave a 1-year update. Zero RFQ would be incredibly big for us to implement. And again, just a review, The zero RFQ process basically is taking your VPE, creating it specifically for a supplier, and then off of that, you can actually create a close to zero time RFQ process between you and your suppliers. We hope to implement this over the next month with one of our sheet metal suppliers. So we have been doing a lot of custom sheet metal work with, and we're talking about parts that we may only make once or twice. So because of that, we want to cut down a lot further on that time with this supplier. Another thing to note that we are working on going forward is a component library. I think this is especially useful if you're traditionally just working on PCBAs. You might find this interesting. As I said, our fire and security division, we do a lot of PCBAs, a lot of wiring harnesses, especially also for transit cold. They've been doing a lot of wiring harnesses over time. Because of this, we have an extensive library of commonly used parts. But the problem is that it's very disconnected between all the business units and all the should costing groups that we have surrounding our area. Because of that, we want to create a common parts library that is specifically in aPriori. And because of that, it would create a even foundation for everyone to go off of. And then off of that, we can actually have everyone working off of the same list. Lastly, we want to expand the group. I think this is kind of obvious. Going forward, we've seen a lot of potential savings and also a lot of realized savings. In one request alone, we were able to realize about 1.1 million in savings. In another project, we were able to cut down a supplier by already $500,000. Now, going forward, we want to create a localized should cost group specifically in each marketplace. This would help create more accurate should costs because these groups, obviously, they'll know the area a lot better than we would. We are, of course, also working on more VPEs, creating more specialized VPs that would actually help us in our costing here at our Syracuse facility. I think that's pretty much it. And now I'd kind of like to open up the floor for any questions that anyone may have. Do we have any questions, Emily?
Yeah, so we don't have any that have come in at this point. Oh, as soon as I said that, we got a first one. So they're wondering, how long did it take to improve the process enough to save that 200,000 that you referenced? And could you elaborate on any other savings that you've seen?
So the process in total, I can think that kind of goes into how long the should cost requests take by themselves. Traditionally, in this project, it didn't take long at all. I would say over the span of about a couple months. It would be even faster now that we actually have a database that we've built for the rotors themselves. But traditionally, how we arrive at these savings and the time span, we're looking at a time span, I would say closer to months, really. We are working on cutting that down. Other savings, though, that we have seen, as I said, we've had one request alone that saved about $1 million, and also another request that had a true realized savings of $500,000 with the potential of another going forward.
Great, thanks. We had another question about what types of tolerances and surface finishes are being used on the rotors.
So for the rotors that we did the should costing for, traditionally we're looking at tolerances in, if you're using aPriori units, we're looking at in 10,000s or even thousands for the tolerances on tail shafts, and then even tighter tolerances on the screw rotors themselves. Obviously, I can't get into too much detail on that, but we are talking about very tight tolerances for the bearing areas on tail shafts.
Okay, our next question is, how close are your should costs to your part costs from suppliers?
It depends. I mean, right now what we're working on is certain things like, for example, with the zero RFQ process, we're obviously trying to get extremely accurate with that. I think right now when we're in the area of about 2 to 3% accuracy compared to what we're getting quoted for that specific request. Traditionally, we've been doing fairly well. I would say if I had to put an average number on it, I'd say we were plus or minus about 5% of what these suppliers are traditionally quoting. But obviously, we're working on accuracy all the time, especially since when it comes to should costing, you have to build up a database over time and also just seeing a lot more, or let's say compressors over time, it will help you overall.
Okay. And then we had another question about the zero RFQ process. So they just noted that it's been around as an idea for a long time. So what about aPriori is help making that a reality?
I think that's a good question. Really, it comes down to a couple of factors. First off, the changeability of the VPs themselves. I mean, when you start looking into what you can change with the proper training, of course, but you can actually go all the way down to your labor rates. You can specifically go into the code and be able to say that this is the process. And also you can put in specifically the machines. I think that's the most important point, especially for us in trying to create a VP that's specifically for a supplier. For us, what we've been able to do is actually go in and assess what machinery we're talking about, and then we can actually incorporate it into the VP. Another big point on why aPriori is so important for that as compared to something else is that you can always go in, always change it, whether it be now or 10 years from now. It's always changeable. That you don't traditionally get that. Sometimes you are just stuck in creating one and then you got to go back and create a whole new digital factory. A lot better than if you were trying to do this on an Excel sheet.
Okay. Our next question is, does aPriori extract gear parameters from the CAD? Are you feeding it into aPriori in some other way? And particularly for gear precision and finishes that might not be available in the CAD, how do you deal with those?
So starting with how we bring in the tolerances and precision, specifically, we actually do put those in by hand. I think that is more or less on us than necessarily aPriori, though. I know that we could do that going forward. It's more of a preference with our design engineers right now. But traditionally, right now, we're doing that by hand. And then what was the first part of that question again, Emily?
Just about which gear parameters are extracted automatically from the CAD and which are fed in by the user.
For the actual rotors themselves, as far as the gear parameters, they're all fed in to aPriori. We don't actually have to feed anything in for that. Now, as I said, it took us about a year to get to the point when they actually would recognize the geometry correctly. At first, it just wasn't sending it right to gear hobbing. But now that we've actually worked with aPriori, giving them our own examples, we've actually been able to achieve the correct processing on that.
Yeah, and to clarify, that was added back into the baselines too, as well. So that's not something that's just unique to your VP, which is great as well.
Correct. I would say we were more of the guinea pigs.
Okay, so then we have another question about if you have any guidance when it comes to creating should cost models for castings, and just how confident are you with the cost being provided by the models?
So the guidance I would give on specifically castings is be aware that unless your models are, if your models are like ours traditionally, there's been some difficulty. There's been a disconnect between design engineering and then your final casting model that goes out to the supplier. Specifically, if you bring it into aPriori, what you might see right off the bat is lack of draft. You might also see radius bends that aren't correct. I will warn you right off the bat that you will most definitely see those things, but don't be alarmed by it. It's okay. Go through your costing, go back to your design engineers, talk to them a little bit about it. Or as we do on our team, traditionally, we might actually add that back in ourselves using our own judgment. That's how the subject matter experts really help. As far as my confidence, I think overall our team is highly confident in the casting and all the process groups that you've seen in aPriori so far. We haven't really come up against anything which is really begged off. Traditionally, though, I will say that, especially in the beginning, we had to really have a close eye on it. We had to build our own confidence. And I would suggest that to anybody that starts using this tool is just be aware you got to build your own confidence in it. And it's okay to call things out. Just go through the process properly to try to figure out what's going on.
Okay, great. So then our next question was a kind of a follow-up on what we talked about before. So he was just asking for clarification on the out-of-the-box aPriori solution, and if you had mentioned that that was unable to solve the rotor should cost problem, and kind of what additional work was required from aPriori to complete the solution. So I don't know, Tristan, if you want to take an initial stab at that, and then I'm happy to kind of give a little more, background from our side as well.
Yeah, I was going to say that. So for my initial stab, I'll just say, it really on our part for Carrier, how we kind of came up against this is we literally just tried it. It tried one rotor set. It obviously failed, and we kept trying a couple others. They also failed. So that's when we started feeding in the models to Emily and also the entire team there at aPriori. And I will say that going forward, really all we have done is provide a few more extra examples over the past year to kind of help better it.
Yeah, and I guess kind of from the a priori side, it was just an issue with the geometry recognition. So the rotors that they were providing to us weren't being extracted in the way that they were expecting. So our geometry team took a look at their parts and then updated the engine there to make sure that they were properly extracted. And as I mentioned, that was a change that was introduced into the baseline product. So that's something that, now exists as part of our product moving forward and isn't unique to their BPE. So for our next question, we had someone asking about, you mentioned 2 to 3% from supplier quotes that your part costings are, but how much, so how many suppliers do you have that quote that kind of parts?
We here at Carrier, we do our best to do dual sourcing at the very least, if not more. So I would say we're doing about maybe 2 to 3 suppliers on each request as far as a single part goes. But yeah, I mean, it's about 2 to 3% if I had to put an average on it. But like I said, especially for the zero RFQ, we are specifically working with that supplier trying to get a better or a more accurate should cost, specifically, hopefully going into their factories and actually looking at all their machinery. But yeah, I mean, we're looking at about 2 to 3 suppliers probably for each part. It depends on the part, though. We have a lot of we've been around for so long that we have a lot of legacy suppliers that we trust, and sometimes we don't do more than one sourcing.
Okay. Our next question is on, did working with aPriori during the solution process of rotor costing cost extra money on top of the software licensing? I don't know if you want to speak to that, Tristan, or you want me to kind of take that one?
I mean, yeah, I'll just let you take that one.
Yeah, so for that one, I guess it's kind of twofold. So I am the expert services consultant for Carrier. So I worked with Tristan and the team to configure some of the custom processes surrounding the rotors, but the actual change of the geometry extraction itself was something that our product team did independent of the expert services and the extra costs associated with that. So the next question we have is, how responsive was aPriori in solving the rotor should cost issue that you saw?
Oh, extremely responsive. I mean, and I want to just say that overall over this past year that we've been working with aPriori, traditionally, I mean, it's as simple as an email, and then a team member, specifically usually Emily or someone else, even gets back to us in really most of the time the same day. So as far as a response time, it's extremely good. I'm no complaints here at all about response time.
Okay, our next question is, how long has it taken or do you expect until your zero quote supplier has or will feel confident to accept the no bid process?
As far as starting out, I mean, we've already approached them on our own end and talked to them a little bit about it. But as far as building confidence, it's going to take a little bit of time. As I said, we hope to have it implemented in over the next month. But there's been quite a number of months now where we've been going back and forth with not only the supplier, but also ourselves in trying to implement this process, because you have to remember, it's not even just the fact that you're trying to get a supplier to trust in it. You also have to get yourselves to have faith in it, and also your design engineers, finance, and supply chain. So there's a lot of people that need to see the process and be worked into it.
Okay, great. And then, yeah, we just had one more question. I know we're at time here, but I think it's just a simple one, asking if you've ever tried user guided modules for parts that don't have 3D models.
Yes, we've done that a couple of times now, and I think we got extremely good results.
Okay, great. Then, yeah, as I said, I think we're at the end of the time here. So thanks, Tristan, and thanks everyone for attending the session. So thanks again, and have a great day, everyone.
Thank you.